Alright, this is Concept 1, Classification of Matter Notes, and this is specifically for honors students. So make sure if you are not in the honors class that you go ahead and find this video for the non-honors group, because this one's going to go into a more detail than you need to know if you're in the CP class. But for honors, we're going to dig a little deeper this time. So here we go. First, we need to know what matter is so we can start this entire unit about matter. And it is anything that takes up space and has mass. And we can classify matter into different categories. And the first two categories we split all matter into is matter can either be a substance or a mixture. So we're going to work off of this little flow chart as we go through these notes, and we're going to add on to it as we further kind of sub-classify each of these categories. So first, a substance is where all the particles in matter are identical. We would say that they have a fixed composition within them, whereas a mixture is two or more substances that are physically combined and they have a variable composition. It's not the same throughout, and that's going to make a little bit more sense as we dig deeper. So let's talk a little bit more about substances. Substances we can subdivide into elements or compounds. So elements are what we find on the periodic table. They are considered the simplest form of matter, and we use them to make more complex substances such as compounds. All atoms in an element are alike. They're all the same. So for example, all the atoms of hydrogen have one proton in them. And they tend to have 0 neutrons and 1 electron also. So they would all look the same. An example of an element is helium. All helium atoms have 2 protons. This picture balloons because the helium is in these balloons, making them float. So that is what an element is. Now, elements can exist kind of two ways. We call them monatomic or diatomic. A monatomic element would be elements like helium and argon and neon that from a molecular level, they're stable just as an individual atom. So if I was to zoom in on them molecularly on a bunch of atoms of the element of helium, this is what I would see. They would all look the same. They're just one individual atom. Diatomic elements are elements like oxygen and nitrogen and hydrogen that are most stable when two of them are bonded to themselves, basically bonded together. So oxygen in nature is always 2 oxygen atoms bonded together. So it's always O2. So from a molecular standpoint, it would look like this. It's still only atoms of oxygen, which is what makes it an element, but this is what it would appear like. Same with nitrogen, N2, which makes up most of the atmosphere, hydrogen gas, H2, that kind of thing. Now, this is different from a compound. Okay, a compound is another type of substance, but it has to be 2 or more different elements, and they're going to be chemically combined, and it's always going to be in some sort of fixed proportion. You can break the elements apart, but it takes a chemical reaction to do it. And because they're chemically combined, it's a totally new substance. So the compound has entirely different properties than the elements that make it up. So a couple of examples. Sodium chloride, NaCl. It is 1 atom of the element sodium bonded to 1 atom of the element chlorine. This is a 1-to-1 ratio. It's a fixed proportion, but it's table salt. So this is what you eat all the time on a lot of your foods. Sodium on its own as an element, though, is really explosive. Chlorine on its own can be poisonous. When chemically combined to make sodium chloride, though, it's something that you can really safely eat because, again, it's a totally new chemical substance and the properties are different. We also have water. Water is always 2 hydrogen atoms bonded to 1 atom of oxygen. It's a fixed proportion. Sugar, C6H12O6, 6 atoms of carbon, 12 atoms of hydrogen, 6 atoms of oxygen bonded together. That's what we're looking at here with compounds. Alright, zooming in on substances from a molecular viewpoint, if you will. Again, they look different molecularly. Notice the difference just between these two pictures. All right, an element is just one substance. It's the simplest form. We said oxygen, even though it's O2, look how it's the same all the way throughout. It's the simplest form. Whereas a compound is two or more elements chemically combined. Like carbon dioxide, it'd be CO2. Notice how this looks different from this. Still a fixed proportion of 2 to 1, but it's definitely different compared to this. All right, let's talk about mixtures. Mixtures can be classified as heterogeneous or homogeneous, so that's how we can further subdivide them. Let's talk about homogeneous first. These are where the components are evenly distributed out on a microscopic level. Another word for a homogeneous mixture is a solution. This is where one substance gets dissolved in another, like lemonade powder in water. Solutions are just another name for homogeneous mixtures. They usually appear blended. They look entirely the same throughout. Examples are bleach or lemonade or blood or black coffee or coffee with sugar dissolved in it. That kind of thing. All right, next is a heterogeneous mixture. And these are substances in the mixture are not evenly spread out. We can either see the different components easily, or if we let them sit, those components will separate out over time. So kind of the easy examples are like salad dressing or cereal. Sorry, my dog is, she's snoring right next to me, so you may hear her snoring in the background. But salad dressing or cereal, have those different components that are really easy to see. Paint and peanut butter, these are heterogeneous mixtures that are a little bit trickier to identify because they may appear the same throughout, but if you actually let them sit for a while, they will separate out to different components. So paint, you always have to mix before you get started. Or peanut butter, you get that oily layer on the top. That kind of thing is what makes it heterogeneous. Looking at it from a molecular standpoint, a homogeneous mixture, there's an even distribution. Homo means same, so it should appear the same throughout, like salt water. Look how evenly distributed these two different components are. Whereas a heterogeneous mixture is an uneven distribution. It's different. This would be like salad dressing. Look how this isn't as evenly distributed, all these different parts to it. Now, we can even further divide heterogeneous mixtures into colloids and suspensions. These are often the tricky ones. These often get confused with homogeneous mixtures, but don't let these fool you. Okay, colloids especially. These have small particles dispersed. Now they are evenly dispersed throughout the mixture, but we can still point them out, which is what makes them different from a homogeneous mixture. They are larger particles than what you would find in a homogeneous mixture or solution. This is things like fog, milk, humid or dusty air. It does appear the same throughout, so it would maybe trick you to think it's a homogeneous mixture, but actually there are small particles dispersed throughout them. Milk, if you let it sit out too, it can kind of separate out on you. All right, this is different from a suspension, which is a little bit easier to identify. A suspension is larger particles uniformly distributed, but they settle out of the mixture over time if you're not keeping them mixed. So they would settle out to these two pieces. That's what we see with oil. Anytime oil is put in water, sand in water, muddy water, the Italian salad dressing, those kinds of things. And these make it possible for us to witness something called the Tyndall Effect. So this is pretty cool. This is the scattering of light by a mixture. It's basically, light diffraction, like we learned about in our waves unit. But only colloids and suspensions have particles large enough to do this, so we don't see this with homogeneous mixtures or solutions. We can't witness this, but we can witness this here, and that's where, see how we can see these rays of light coming off of the sun or coming through these trees. It's because there's these particles suspended throughout the mixture, like in a colloid or suspension, that makes it possible for us to see this scattering of light, which is a pretty beautiful thing. All right, last but not least is this flow chart that I think really helps us be able to classify different types of matters. So this would definitely be something that I would encourage you to memorize. So all matter, again, is classified into substances or mixtures. Substances have fixed proportions and can be either elements, which are on the periodic table, or compounds, which are two or more elements that are chemically combined into a new substance. Mixtures are physically combined. We can separate them out physically. Heterogeneous have different compositions throughout. Homogeneous have same. All right, now we're going to practice classifying.